Welcome to MSDS 458 AI Deep Learning course. This course introduces deep learning data architectures and their solutions. Deep learning is applied essentially for big data, which means analysis of images, audio, video, and text. However, we will cover predicting images, generating new images out of training images with spatial data using CNN, temporal data using RNN, LSTM, and developing applications in natural language processing. Furthermore, we will also critically evaluate the challenges in the AI deep learning fields in applying them for predicting human behaviors and health outcomes. In this first Sync session, I will introduce the course, the Canvas portal, where you can access the 10-week modules, assignments, discussion board questions, and this course-specific mini capstone called Final Assignment. The AI 1.0 was designed based on painstakingly detailed processes of humanly figured out if-then-else type context-relevant knowledge rules. This approach did not lead to faster and better solution architectures for applications as we received more and more data. In AI 2.0, where we get huge amounts of data and new ML techniques, we were able to let the machine figure out the if-then-else knowledge rules, and this changed the AI development processes. So this picture implicates that data is the foundation for artificial intelligence. And what is artificial intelligence? It is mimicking human decision making at scale using all types of input data, however they are complex in terms of the data architectures, but developing complex ways of combining rules and expanding to huge amounts of data. On the other hand, machine learning refers to automated methods that uses math, stat, computational models in getting productive answers. Finally, deep learning means it is essentially an artificial neural network having deeper and deeper hidden layers to locate signal intensities in the data, whatever the type of data, or whether it is voice, images, text, and videos, and differentiate various states of key characteristics of samples in terms of those intensity variations. So, what is the difference between machine learning and deep learning? In machine learning, features, also called the factors or attributes that captures the signals from the data, are defined by humans, and the collection of algorithms are everything other than artificial neural network. While in deep learning, we do not have to engineer the features, and it is always about artificial neural network. In the next few slides, I want to bring out some quintessential AI applications that can give you the characteristics of AI apps when you are designing or thinking of designing AI apps. The first one is Google Traffic Jam app. It's amazing how data from Google subscribers' phone its pulse data, nothing else, just the pulse data, and how the pulse data in a certain segment of the road are changing its latitudes and longitudes pointers. And just using that cluster of automobile pulse data, Google estimates the traffic jam, and it is amazingly accurate. And it works 7/24, and with little change, it works globally. Isn't it amazing? I think it's amazing. The second app I want to introduce to you is what is called the Sky Guide application. It is about celestial movement of sun, planets, star systems. And I believe this is another true AI applications. Why do I say that? Actually, there is a video here. You can click and play that video. When you play that video, and remember, I was taking this screenshot video from my Apple iPhone, and I was from Fort Worth, Texas, okay, and I was moving the app, looking at the sky from east to west to track the sun and where it was around 2 p.m. And it is in Gemini cluster. That's what I just now showed. The interesting thing is that, and it shows you as you move the phone around the sky, whether the weather is bad, raining, cloudy, or not, you can see the current position of all the planets of our solar system and where they are located in relation to the various stars, and that's what this application. So why do I say it's an amazing application? It works 7/24 again from any part of the world, and it gives you the location of the planets, sun, and star systems, and it works irrespective of what is the weather is, even when it is cloudy, totally dark night, as well as that raining. And I think it's amazing. The next application, truly AI application, is what is called Socratic. And it's a learning app from Google that helps high school and university students understand their subjects and schoolwork, sometimes also called homework. It uses Google artificial intelligence and search technologies to connect students to help them with their educational resources and their needs from the web and sites such as YouTube. It teaches algebra, geometry, trigonometry, calculus, biology, chemistry, physics, earth and environmental science, US and world history, and literature. Amazing, isn't it? Again, it is not discriminatory based on who you are, what religion you practice, what language you speak, where you live, what gender you have, and so on, dot, dot, dot. And it is working 724, and it is helping people around the world. Every one of them have equal opportunity for this knowledge helper. Then next true AI application is something what I like is the English language speech assistant, and it helps people to pronounce more clearly, speak more easily, and more confidently. And it is again irrespective of where you live, what you practice, what gender you are, dot, dot, dot. And it works 724 for people around the world at the same time with the same quality and efficiency. So, what are the characteristics of AI solutions based on ML or SL? I mean, machine learning or statistical learning. In addition to ANN, that is artificial neural network. So, what are the characteristics of AI solutions that often involves big data, which means involves images, videos, audios, and text. It works 724 beyond human level service. It behaves like an intelligent advisor that provides intelligence to the interacting person. The level of intelligence is often same or better than humans irrespective of the situation. It provides equal treatment to the user irrespective of their language, religion, region, gender, any differential aspect of humans. It's automated, credible, application based on science and behavioral needs of individuals. And it uses all possible data points that an app can access, which is beyond human level. It can speak in any language and create visually appealing solutions. Again, beyond human level. It doesn't complain, it doesn't get tired, or it doesn't ask for human level rest-seeking behaviors. So quality of implementation will not suffer fatigue syndrome. This is great as long as the data, science, and behavioral implementations do not carry any bias or ethical issues. So that's essentially what defines as characteristics of AI solutions. And it is amazing. It brings us the new world opportunities equitably around the world with same efficiency and accuracy. Let's move our discussions about characteristics of AI/ML solutions and case studies with the following list. Fraud detection, often where algorithms are heavily dependent on human level interaction, as humans figure out tricks the other humans use to defraud a system, is better suited for AI because the speed and the depth and width of data to use are huge. And image recognition is it's not a normal Excel type rows and columns types data architecture. It's not a matrix type data. It's an array. And the array of data points contain numbers between 0 and 1, 0 and 25, 255 for each of the color or GB, red, green, blue, and humans cannot figure out what that color is based on the combination of these three numbers. But machines can do. It's the right way to apply machines to figure out the characteristics of the image. And we'll see an example about pneumonia detection based on chest X-rays. Voice recognition, again, a good example of that is an early diagnosis of Parkinson's is better suited for AI because different segments of populations have different voice patterns, and also different languages have different voice patterns, and on top of it each individual will have different voice patterns, and AI is beautifully suited to solve this problem. Likewise, medical speech, transcription and intent, as well as medical symptoms, text and audio classifications are very well suited for true AI applications. It's not about just building a regression model, logistic regression model, and so on. I'm taking you to an imaginary space where the data are not easy to interpret. Human level training is not helping us to figure out those things with the human vision. And AI with ML solutions, machine learning solutions, can help us achieve those. And that's what I am kind of listing here. For example, multi-labeled text classification from any collection of library. In this case, I'm talking about healthcare. PubMed holds all health-related publications in its library, available through National Institute of Health. And we call, supervised algorithm there. Clustering of COVID-19 papers, we use unsupervised algorithm there. And classification of, for example, health of a fetus as normal, suspect, or pathological using cardiotocograph data, which monitors fetal health rate using Doppler ultrasound and uterine contraction by strain gauge. And these things are not humanly interpretable easily, but well suited for AI development work. So I'm giving you some examples here to make you think that AI solutions have different data architectures, usually not humanly possible to read and interpret them. Forget about predicting at scale, yeah. So these examples, great applications that I showed you in the earlier slides, as well as the list here, are all meant to provide confidence in such concepts. What defines a true AI solution and how it can handle complex data, different types of data, and also huge amounts of data. Quickly, I want to say that, you kind of saw earlier what's ML versus DL. What is the difference between ML versus DL? So I'm going to skip this one. But you can see in graphical form, ML uses expert knowledge about attributes, or what is called the features. And deep learning uses, in categorizing the pneumonia cases, for example, it uses various layers of summarization of data. These summarization are accomplished using what is called the convolutional computations, and then reducing that size using efforts to find out where the maximum signals are obtained, which is called max pool method, and then again repeating that, with smaller and smaller data size, array size, continuously going, reduced array size, picking up the max pool, which is the maximum signal places, and using, finally flattening that into a multi-layer perceptron, and that variations in the max pool signals distributions tells us the variations in the images, and hence we will be able to predict the images. That is the idea. You may be wondering where artificial intelligence sits among the various courses and the tracks, specialization tracks that MSDS program offers. And I have provided the link URL for the huge collection of various subjects in the link https://sps.northwestern.edu/masters/data science/curriculum-specializations.php, which is there in the title section of this slide. So I encourage you to go to that page, and you will have a chance to look at the various core courses. For example, which are all in yellow color. 402 is about Introduction to Data Science and Research Practice, and 403 is about Data Science and Digital Transformation. 420 is about Data Systems and Data Preparation. 422 is about Practical Machine Learning, and 460 is about Decision Analytics. 475 is about Project Management. 480 is on Business Leadership and Communications. 485, which is again part of the core courses, is Data Governance, Ethics, and Law. On the other hand, we have many electives. For example, 410 is Supervised Learning Methods. 411 is Unsupervised Learning Methods. 413 is Time Series Analysis and Forecasting. 430 is Python for Data Science. 431 is Data Engineering with Go. 432 is Foundations of Data Engineering. 434 is Analytics Application Engineering. ... All these things you can see in the URL link that I have read out for you earlier as I introduced this particular slide. And we have some specializations also. Okay, so the specialization, for example, artificial intelligence is blue coded, green coded, and the subjects are 453, 458. Okay, and 453 and 458 are the following. Okay, it's green coded, right? 453 and 450. 453 is about data. 453 is about natural language processing, and 458 is about artificial intelligence and deep learning. So take a look at this page, and you'll be able to make sense how the core courses are connected to the various specialization. And what are the specializations we have? Analytics management. Another one is analytics and modeling. Third one is artificial intelligence, and fourth one is data engineering, and fifth one is technology entrepreneurship. Often there is a common question as to what platform one should choose for deep learning. Is it TensorFlow or Pytorch? The foundation for TensorFlow is Keras, and TensorFlow subsequently bought or folded Keras into its management, and Pytorch uses the components of TensorFlow. And if you play this small video, you will be able to go through a short introduction on what are the relationship among these Keras, TensorFlow, and Pytorch, and what conditions you can choose one or the other, and why you are not going to be at fault or making a mistake in your decision if you choose either one of them. But it's a little bit nuanced one. And finally, this video gives you, in what order you can be exposed to. So from that point of view, I would say, uh, you start with Keras and then move into TensorFlow, and then finally, with this training, you can also become good at Pytorch. Okay, so we don't throw away anything, because the way the foundations are built, this is the order in which it is built, and it is the right way to keep working towards your coding expertise. But if you're a hobbyist, so that is for so that's a kind of introducing you the various components of coding platforms, Keras, TensorFlow, and Pytorch. So I encourage you to play through this one fully, and go through the nuanced differences and why, in what way you can make your decisions in terms of adopting Keras, TensorFlow, and Pytorch. This course doesn't have any exams, but we have 4 assignments. 2 computer vision assignments, 1 NLP, and 1 open assignment, which is considered as final assignment. We'll be using Jupyter Notebook and Keras. Keras is very foundational set of codes with options, low code options, and so it is easy. And also we will use Seaborn Python visualization package. The main point here is that you will have to explore and experiment, and that's an important point of deep learning, artificial neural network in general. The tuning of parameters is a common complex step, so that's part of the exploration and the experimentation. And also there are multiple architectures of deep learning that can give the same solution, but that might introduce more parameters. So you have to experiment with the number of parameters, fine-tuning with the other parameters of deep learning. And so experimentation and exploration is a very important part. The course material uses some key books. I would say the Chollet 2nd edition, which is free on O'Reilly, and that's available in your Northwestern Library account. And also Jason Brownlee's book on deep learning are very important books. We will go through some lecture recordings also that I will make it available for you, where we will talk about conceptual, technical, and Python codes. Our TA, not Daniel Jensen, but Krishna Prabha, will walk through the codes during week 2, 4, and 6, or by myself. Either one of us will do that using Jupyter Notebook. And we also have a GitHub page for you, and we will provide sync sessions on every alternate week. The first week I'm not able to be in person because exactly during that time I'll be on a flight. So we'll definitely meet week 3, 5, 7, and 9. Course plan is as follows. primarily using Chollet book. So in week 1, we talk about learn past, present, and future of AI. Week 2 is about multi-layer perceptron in action. Week 3 is simple neural networks, architectures, and design principles. We will cover 4 chapters by then. And first research or programming assignment comes in. And week 4 is about deep neural networks, explaining various architectures and design principles here. And week 5 is about spatial data processing, broadly coming under convolutional neural networks, highly used for images. Some authors also use for text analytics. And week 6 is about temporal data processing, which means time-based, or which is prior, which is later type information, not necessarily purely completely time series type data, even though RNN and LSTMs are used. Recurrent neural networks and LSTM, long and short-term memory models, are used for time series data, but we're talking broadly speaking as temporal data processing. That means what comes next, what comes before type information. Sequential data, that is also sequential data processing, that includes sequential data processing, NLP, and RNN with RNN. In such applications we are talking about RNN, but for NLP. In week 8, we will be introducing you to generative versus discriminative methods in deep learning that's used for creating new solutions, unknown solutions, as well as new applications in arts and methods that uses competitive learning networks. In week 9, I will introduce you reinforcement learning, and finally in week 10 we will complete with the final assignment. That is the 4th assignment. The grading is based on class participation through discussion board questions. 4 assignments, 3 of them are learning assignments, and 4th one is the final assignment that showcases your full learning from this course. The discussion board affords you 100 points, and each of the mid-term assignments, 3 of them, gets 100 points, so 400 points, and final assignment gives you the opportunity for another 100 points, so a total of 500 points that determines your final grade. And the letter grades are same as usually what you hear, like 93 to 100 is A, 90 to 92 is A minus, 87 to 89 is B plus, 83 to 86 is B, and so on, which is given in the bottom portion of the slide. Now, coming to the Canvas course shell, I have the link here for our section, and if you click on that, it will take us to the Canvas portal for MSDS 458 section 57, and momentarily I will go there and walk you through the various modules. In assignment 1, artificial neural network will be introduced, and we will do a case study analysis of figuring out automatically through the machine learning process the handwritten numbers between 0 and 9. And each of these handwritten numbers have a total of 784 pixels, the columns versus rows. When you multiply them, then you get a total of 784 pixels, and they will be considered as input. And we will do many experiments in this one. The first experiment being analyzing it as an artificial neural network with 784 input neurons or nodes and one hidden node or one hidden neurons, and output obviously has to be the 0 to 9 neurons, output neurons or nodes. So a total of 10 output nodes. So that will be the first experiment. So if you have, for example, 50,000 training set, if the total data set will be divided into training, test, and validation sets, and which means, if you have 50,000 in your training set, after training, weights of output of one hidden node after sigmoid activation will have 50,000 values. We'll do some exploratory analysis, try to understand intuitively how these 0 to 9 handwritten nodes will be identified or will have challenges in getting identified. In experiment 2 of the same data, we will introduce two hidden nodes, and the input nodes and output nodes are same, but we increase the number of hidden nodes to 2, and we will compare this with the previous experiment, which is experiment 1, where we have only one hidden node. In experiment 3, we will explore with more hidden nodes and find out what could be a best model. So in all these processes, we will be using the ROC curve and other metrics. Okay, the true positive rates and then true negative rates. Also 1 minus false positive rates. As experiment 4 with the same data, we will do PCA to do dimension reduction. The dimensions is 784, but let's say we reduce it to around 200 dimensions and see what is its performance. And finally, with the same data, experiment 5, we will use the random forest and get the importance scores of 784 features, pick up the top 70 features as an example, and repeat the experiment 3. Okay, that is the what was considered as the final model with the artificial neural network. And again, we will compare and see where the results differ, and why artificial neural network is has power or some other challenges with artificial neural network. This is because we will be using artificial neural network as the basis for all other applications that are coming in under the deep learning approach, because we will introduce more and more hidden layers to capture automatically the features that explains the prediction, that performs the prediction. So in general, the assignment rubrics will be, you have to write a kind of summarized work. Abstract will get 5 points. Introduction of the problem will get 5 points. Literature review will get 5 points. Methods and whatever you have used and reviewing it, and talking about the program you did, and data preparation, exploration, and visualization will get 40 points, the chunk of the work, big chunk of the work, and explaining the results will be getting another 40 points, and finally conclusions will get 5 points. So total of 100 points will determine your score, total score for the assignment 1. Okay. In the assignment 2 and 3, I told you that we will continue to use image analysis, and in assignment 2 we will use image analysis, and in assignment 3 we will do NLP. And finally, for the final projects, I want to bring out some of the important conditions you will have to work with. And the first condition is don't use the first 3 assignments for the final project. You can use Kaggle datasets. You can use UCI repository. Can use datasets in Keras or TensorFlow, and also you can use dataset from your work. Remember, use if it is a structured data, I recommend not to use neural networks. Okay, if it is a big data, which essentially means images, audio, video, text, you are encouraged to use artificial neural network and its extension called deep neural network. Okay, so that's an important consideration to think up for your final project. So next step for this week is that introduce yourself. If you haven't done so already, read first 2 chapters of Toby Walsh's book, read the first 3 chapters of Chollet book, work on the discussion board question, do research on XOR problem, listen to the lecture on building blocks posted under week 2, and peruse the code for assignment 1. So this is for next week anyway. So for now, just do your week work. I also want to introduce you the MLOps, that is machine learning operations life cycle, and this is a big picture. It's basically we are talking about how do we work with data, how do we build a model, how do we store the model to give predictive results in the implementation, how do we use that in the implementation or an application, and how do we monitor the results. That is basically the MLOps. Okay, it's not a big stuff other than these very basic steps. Basically as an ML engineer, you will be doing these steps. That is making sure that the data are accurate and well documented, and preparatory works are done, feature engineering is done, and then we also make sure that we follow the best practices in modeling, and further we make sure that these outputs are well articulated, interpreted, and used in the implementation of an app. Okay, so that's broadly speaking MLOps, and people write big documents for this, but those are the things that we will be concentrating anyway in practice. Okay, and I want to quickly get you the modeling strategy, end-to-end ML projects. So there are 4 components here: problem formulation, data quality, EDA work, analysis, modeling, and conclusions and implementation. This is a broad collection of steps that you follow in modeling specific activities. Take a look at this one. For example, everything starts with the problem formulation, which means everything starts with the fundamental question that you'll be defining and listening to the stakeholders in terms of what are the fundamental questions that you need to address in developing a solution. That defines the problem formulation, request for data strategies, and then you receive the data, do the data quality work, do the EDA work, and analyze and do the model building work, interpret it, implement it, and then this monitor the results of the algorithm, and then this cycle goes on, because in the second version you'll have to verify whether the model performed well according to the model formulation that started this work. So take a look at this slide. This is again a different version for modeling strategy, a component of MLOps. Okay, so remember, MLOps goes beyond modeling work, specifically beyond modeling work. I also want to bring out this meta reference of select AI course contents in top US universities. This is something I posted in LinkedIn. Follow me in LinkedIn also. I am fairly active in LinkedIn. Almost every week I'll have at least few important high value postings that what I think are important for ML engineers and AI scientists. So take a look at that one. This is all about vision, engineering, video intelligence, and NLP. Okay. I want to quickly get your attention on ethics and AI. The AI is greedy. At least today, that's what it is. In the sense that it tries to achieve the best result, best accuracy, but if the data is biased, if it doesn't represent the various sub-segments in the society, then it will do a great job of the segments that are included in the data set, a great job, and will do a poor job of the segments that are not included in the data set, or even if it is included, it is not proportionately not representing the population. And if it proportionally represents the population, then there are some low incidence segments, will still have problems. So this is very much a human issue. It's a human intelligence, it's a statistician like thinking. So if the bias exists and the error exists in data, AI is not going to do a great job. If the even if there are no bias and errors in the data, there are some algorithms that gives more weights to certain data areas versus others. So there could be some algorithmic bias you have to look into and remove them. And on top of it, interpretation bias. We all carry our own biases. That's where the interpretation bias comes in. And finally, there could be some issues about the implementation bias because of the way the whole MLOps is set up in your office, and that might introduce some bias in the implementation level. So you as an ML engineer have to protect your processes, your solutions from all these bias and errors. And ethical AI is indeed a business opportunity. Consider that way, because if you do a great job compared to your competition, your product and solutions will be used by the entire society, or the people who want to use it will do it, will use it correctly, and will enjoy the benefits of such applications. So here is an introduction about how useful it is. Ethical AI is important and useful and demanded in pharma industry. So I won't go through this much detail. Just you have to read this. For example, a provider supporting organization systematically achieves favorable health outcomes to a subpopulation, but not to another subpopulation. It's an opportunity. A pharma product shows systematic benefits of favorable health outcomes to a subpopulation, but not for another through clinical trial. Though clinical trials did not show these differences, then it's an opportunity. It's not I don't see it as a problem getting frustrated about it. And access to participation treatment equally for all subpopulations. If it is not happening, in other words, the various subpopulations are not getting the benefits of treatment or participation equally as much as good as the rest of the other subpopulation, it's an opportunity. So think of it as ethical AI as a business opportunity. And you can achieve ethical AI at every level: data, analytics, and application layer. It basically comes down to have the right data to measure the gaps in ethical AI applications by subpopulations, monitor reports that show support for every subpopulation, having equitable access, treatment application options, equitable benefit from each of the population governance initiatives, interventions, and outcomes as assured by the Constitution. So the real world AI application, AI engineer has to be part of this. And today, actually, I saw one paper in American Scientist, it is also posted in LinkedIn. The importance of the visionary AI people versus the boots on the ground AI people. Okay, boots on the ground AI people are the ones who worry about ethical AI, and visionary, missionary AI people are the ones who are, want to achieve the extraordinary accuracy by AI engine. So both of them have to work together. That's the conclusion of that article. I have posted it. I'll also post it in. I think I posted it in the discussion general announcement, asking you, what's your take on that. So AI is an enormous opportunity, but just don't think that it's an achievement of high accuracy as the end goal. Thank you very much for everybody for taking your time to listen to this, and let's get started with our program on AI deep learning in this term. Have a great day.